Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are covering module number 4, lecture number 32 on orthographic projections part 2. In this orthographic projections part 2, we are mainly covering point projections, line projections and how lines really appear on horizontal planes and vertical planes. If they are parallel to the planes, if they are perpendicular to the planes and if they are inclined to the planes. These are the basic construction for any engineering drawing. Let us move on to that module. In this orthographic projections, in the last class, we have learned about different kind of projections of a line. For example, a line which is perpendicular to the horizontal plane and perpendicular to that vertical plane, how it really turns out to be in terms of projections. So, for example, one of the line, if it is perpendicular to horizontal plane, the projection of this entire line on the horizontal plane will be a dot point, whereas this projection of this line which is parallel to that vertical plane, we will see it as a true length line, because this AB line is the true length line and its projection on that vertical plane for this case becomes true length. On the horizontal plane it becomes a point, and our notation is uppercase letters or capital letters for true lines, and projections if it is on horizontal plane it will be lowercase letters. If it is on vertical plane they will be lowercase letters with dash or prime. Similarly, we will try to look at a line which is parallel to both horizontal plane and vertical plane, then it gives us true length both in the top view or on the horizontal plane and also on the front view or the vertical plane. Thereafter, we try to look at a line which is making an inclination angle with the horizontal plane. If we are extending it with the horizontal plane, it is making an angle theta, but this line is parallel to vertical plane. In that case, the true length projected onto front view and apparent length will be projected onto this top view. And our usual notation is any line making inclination angle with the horizontal plane, we represent it by theta. This is standard notation. And if this line making an angle with the vertical plane, then we call it phi or phi. In this case, a line making inclination angle with the vertical plane, phi. So, true length we will get it by projecting it on the horizontal plane. Projected length, the apparent one, we will see it on the vertical plane. Let us begin by looking through an example. The first example is a point A is 20 millimeters above horizontal plane and 30 millimeters in front of vertical plane. Then draw its projections. So, let us consider this point A is in the first quadrant. If that is the case, we will be having, let us consider this is the vertical plane and this is the horizontal plane. Our line, if there is a point, this is the point 20 meters above HP. So, let us call this one horizontal plane and this one vertical plane. Point is this, let us call A. This is 20 millimeters above HP. If we are drawing, that will be 20 mm and 30 mm in front of vertical plane. So, this might be 30 mm. If that is the case, we have to draw projections. The way we do these projections is, either we can look from here or we can look from side. It depends on which view we are trying to look at, draw this figure. So, the first thing always be draw a vertical plane. On this vertical plane, the projected one, let us call this, name it x axis, y axis. So, our x axis, y axis pass through this point origin. Project this point A onto vertical plane. So, that note it down A dash, and this one if we are having, that will be 20 mm, because this is the length what we are going to see. Now, project A onto that plane here, then rotate horizontal plane in the clockwise direction by 90 degrees. If we are making, projection goes onto that, and that will be somewhere here A. So, this length will be 30 mm. This is the way we construct. Let us look at the solution. To draw the thing, the easy way is, we have the point A, straightforward projection of 20 lengths is done. Once it is done, we project it on the horizontal plane and then use this origin with that radius, transfer it to this point, which is same as rotating this plane by 90 degrees. So, if we are looking from this side view, try to look at, redraw these projections. The way is, we have this axis, vertical plane. Let us consider these x y coordinates, perhaps at this location, passing into that plane. So, this is horizontal plane, point A projection, let us call A prime, point A project there. Once it is done, from this O to this projection, make an angle 90 degrees by transferring that radius, so that we can get A. So, the steps what we have to do, let us look at on the sheet how to construct this. First of all, draw a line on the sheet. Construct a horizontal plane and a vertical plane. This is the vertical plane. Let us use marking. This is the vertical plane and this is the horizontal plane. We have to know first project point A, somewhere A which is 30 units, 1, 2, 3 units. So, somewhere 10, 20, 30 here and 20 units above, that means 1, 2 units. So, this must be the point A, capital A, that we have to project it onto this bottom. First we always project it onto the vertical plane, because that is easy thing to do. So, project here, similarly project it onto horizontal. Whatever the thing we have projected, that point A prime on the vertical plane. Now, use our compass to transfer this length. So, transfer this projected one from here to there. So, the way we transfer is by drawing an arc. Once we are done, this point we call A. So, now darken these lines. And then this will be (20 units) and this will be 30 units. This is the way we project a point in the first quadrant. Let us ask a question: if the same point A, perhaps if it is in the third quadrant, how to draw these projections? Let us look at an example. The first problem is A in first quadrant. The second question what we are going to ask, there is a point B in third quadrant. Which is something like 40 mm below horizontal plane, 50 mm above in front of vertical plane. Is more like asking a question: if we are having this third quadrant also, somewhere the point B is present, which is 40 mm below the horizontal plane, because this is the horizontal plane. Below that 40 mm and in front of vertical plane, this is the vertical plane, in front or back side, the way how we look at it. So, that is 50 mm, if this one is 50 mm. What will be the projection of this point B on the vertical plane, horizontal plane? For that purpose, what we have to do, recall our last thing. We have to project this point straight away onto vertical plane always, somewhere it goes below. But horizontal thing, the way how we do it for third quadrant, always be clockwise 90 degrees we have to do. So, first of all project there, and then transfer it by radius, rotating it there. So, there we will have this B, there we will have B. It comes top and bottom switches. So, let us look at that problem. So, B point is 40 mm below and 50 mm in front of vertical plane. So, 50 mm is this one and 40 mm 0, 10, 20, 30, 40 somewhere here. So, our point B, let us call it is in the third quadrant there. Now, we have to project that. So, our point B comes to this location. This is what we call B prime. On horizontal plane, we first project it into horizontal plane, then make an arc, rotate this point by 90 degrees. Once we rotate, this point moves on to this point B and this one B prime. If the point is A in the first quadrant, is top view will be at bottom, is front view on the top. So, with respect to this point, we always say whether it is at bottom or with its top. If it is in third quadrant, they will flip. So, what you are going to have is top view at top, front view as it is. That is the way we have to draw the things. If it is in second quadrant, again we project that if it is in second quadrant, we will straight away project this point onto vertical plane, horizontal plane project it, then rotate it 90 degrees, it comes all the way up. If it is fourth quadrant, there also first the point projected onto vertical plane somewhere here, then project it onto horizontal plane, rotate it by 90 degrees clockwise. That is the way we construct this front view and top view of a point on a plane. Let us look at the solution. You see there, when point is in the first quadrant, what we have is A prime at top level and A is at bottom. This is front view and this is top view for a point in the first quadrant. The steps what we have followed is, first of all, one has to draw a reference line xy, this is the xy line. Then mark a point A prime at a distance 20 mm above xy. Point A we projected onto vertical plane 20 mm. So, at 20 mm height we mark A prime above xy, we are in the first quadrant. Then through this point draw a perpendicular line to xy and mark the top view at A at a distance 30 mm below it. Once we are done, this A prime is the front view, A is the top view we will get. Now, let us ask next question. A point D is 20 mm below horizontal plane and 30 mm in front of vertical plane. Draw its projections. Can you guess how to draw this point? To visualize that, first of all we have to construct a schematic like this is the vertical plane and this is the horizontal plane. There is a point D 20 mm below horizontal plane. vertical plane. 20 mm below means somewhere here, and 30 mm in front of vertical. So, 20 mm go down somewhere there, and it is 30 mm in front of VP. So, if I am measuring from vertical plane, this will be 30. If we are measuring from horizontal plane, that will be 20. So, your point D is at 4th quadrant, though we would like to draw projections from the 1st quadrant thing, but the point itself is in the 4th quadrant, that we have to represent by first angle projection technique. If that is the case, what we are going to do, project this point onto vertical plane, somewhere there we will get D prime. Project D onto horizontal plane, then use this radius, transfer that all the way down. So, that point D we will have. So, from reference line, this is the way it is supposed to look like. That means, if we are drawing a projection, it is supposed to be, first draw xy line, locate D prime below it at a distance of 30 mm, at a distance of from horizontal plane it is 20 mm. So, locate 20 mm down, then project this one onto top one, 30 distance we will have. So, from origin make something like 30 mm somewhere here, then transfer that by radius. So, this will be D. So, let us look at the solution on our drawing sheet. So, first of all we have to draw xy line. Name it x axis, y axis. Somewhere origin, pick it O. Now, draw a perpendicular line. On this perpendicular line, what we have to do? Point D is 20 mm below horizontal plane. That means, if we are projecting that 20 mm onto vertical plane, at a 20 mm distance, we will mark this front view. So, 20 mm. So, this is the point where we will have D dash, because it is a projection, and this point 30 mm in front of VP. So, 30 mm project. Somewhere there. But we want to transfer that in the first angle projection. That means, take radius, mark this point, transfer it by arc. If we are doing that, it makes a cut there, name that point D. Now, your line will be this. This is vertical plane. So, front view will be this one front view and this one top view. Top view of this length what we are going to see all the way from origin to D point, and front view will be from origin all the way to D prime. This is the origin, let us call. Let us look at the solution. So, as I mentioned, point is here, project that straight away to A prime, D prime, this is supposed to be D prime, and this is d, small d. So, projected one we will have it by rotation to this point. So, this I am sorry, this is supposed to be d prime and d. So, let us look back our solution on the drawing sheet. Here we just have to mark the dimensions, like this line will be 30 mm. So, you use by arrows, double arrows, and this will be 20 mm. So, this will be 20 mm. Okay. Let us move on to the new example. Let us ask a question. There is a point A which is 20 millimeters above horizontal plane. Let us pick the part 1. There are 3 parts. The first part is there is a point A 20 mm above horizontal plane and 25 mm behind vertical plane. If that is the case, can we draw projections of this point A? For that, first what we have to do is visualize that by making a vertical plane. Perhaps that might be the horizontal plane, now what we have is point A 20 millimeters above horizontal plane. Above 20, it can be here, it can be there, but it is 25 millimeters behind vertical plane. So, in front of vertical plane is this is, let us make it in front, and this is behind. If that is the case, point A will be somewhere here. Let us call point A, which is 25 millimeters behind VP and 20 millimeters above HP. What we have to do is get the front view and top view of this point using first angle projection technique. For that, what we have to do is always project this point A straight away onto vertical plane. Note down that point as A prime. Then project this point A onto horizontal plane, then rotate it by 90 degrees. So, rotate horizontal plane by 90 degrees to mark that point A, because this distance is 20 from behind 25 VP. So, point A comes all the way up, because 25 mm we are transferring it on the top direction and 20 is this. So, the 25 point, when we are rotating it by 90 degrees, it always goes to up. So, let us draw it on the sheet. Something maybe let us draw vertical plane in that way. Name it, this is vertical plane, this is x axis, y axis, and first thing what we have to do is project this point A in front of vertical plane by 20 mm. So, 20 mm somewhere there. This is, let us call A prime, and 25 mm behind V p, maybe this point. Transfer that point somewhere there. Let us call that point A. The dimensioning always be required, and what we can do is, on this side let us make it, this is supposed to be vertical lines 25 and this will be 20. That is the first part. Let us move on to the second part. At the second part, point B 25 mm below HP and 20 mm behind VP. So, behind VP is here, below is this. So, point B must be somewhere there. Then project first of all this point B onto vertical plane. So, for that purpose what we have to do is below is 25 mm. So, leave some gap, and if you are looking at this sheet, minimum 30 mm gap has to be given for any construction the projectors thing. If that is the case, from projector 30 mm I have to give, and go ahead construct this below 25 mm. So, somewhere here below 25 mm, mark a point, call this one B prime, connect these lines, this is the front view, this is okay. B prime is done. Then behind VP 20 mm, so locate behind 20 mm somewhere there, because it is third quadrant, and what we want to really project is project this point B onto horizontal plane, rotate it. If we are doing that, it will be somewhere projecting it 90 degrees. So, our point will be somewhere there. So, let us join that point and let us call B. The third point, point C 20 mm below HP and 30 mm in front of VP. So, point C first of all locate somewhere below, but in front of VP means here. So, the C point is somewhere there. So, how we will construct? Project this C point onto that, project that and rotate this horizontal plane by 90 degrees. To do that, what we have to do, again leave 30 mm gap between the projectors somewhere there. On this line we will have these projections, name it as vertical plane, (20 mm below HP. So, mark a point, join that, name that point as C prime and 30 mm in front of VP. So, in front of vertical plane, which we can note it here also, if this is vertical plane, in front of that 30 mm and rotate this 90 degrees. Onto that plane. Then we will have C point also. Once it is done, we can always make dimensions this one 20 mm below and this one 30 mm. This is the way we construct projections of lines. Check our solution. Both the points A prime A on one side above that xy line. If point B is 25 mm below horizontal plane, 20 mm behind VP, the solution will be B and B prime will be on the opposite sides. Similarly, for point C below HP in front of VP, both the points on one side, but that is below xy line. Check your solution with the actual solution. Okay. In the next class, we will learn more about these projection techniques. Thank you very much.